Hello, dear friends. This is Dr. Mohammad Aminul Islam. Welcome to Aminulchem Innovation. In this video, I will explain how to calculate thermodynamic parameters for effect of temperature. Here I have shown how to calculate C and Q for effect of temperature. This video is very important, so please do not skip. Well, in order to determine thermodynamic parameter, you need to carry out adsorption isotherm at least 3 to 4 different temperature. For example, I have done adsorption isotherm experiment at 25, 35, 45, 55 at 4 different temperature. And experimental condition is this: m equal to 10 mg, volume 25 milliliter, and concentration at 1, 5, 10, 20, 30, 50 initial concentration of methylene blue. So at 25 degrees Celsius, uh, CE and QE was calculated. For example, these are the initial concentration, and this is the absorbance of methylene blue at 664 nanometer, measured using UV visible spectrophotometer. So this is the standard absorbance of methylene blue solution at different concentration. This is the absorbance for solution after equilibrium at different concentration. So you can easily calculate C here. For example, here I have shown C. C is calculated using C16, that is absorbance of sample into absorbance of into initial concentration divided by absorbance of standard. So using this formula, you can easily calculate C. Then you need to calculate QE. QE means C14. C14, that means initial concentration minus J15. C, equilibrium concentration, in into 50 volume of solution divided by mass. So you can easily calculate QE. So if you scroll to right, then all will be calculated. So here is our CQE. Similarly, you can carry out adsorption isotherm at 45 degrees Celsius, 55 degrees Celsius, and calculate C and QE. And after carrying out adsorption isotherm at 4 different temperature, you can plot like this. These are the adsorption isotherm at 4 different temperature. Now, using this data, we can calculate adsorption thermodynamics, that is thermodynamic parameter: Gibbs free energy, enthalpy change, entropy change. Let us start now. So, in order to calculate thermodynamic parameters, you need to calculate equilibrium constant C, and C is dimensionless. So, if you want to make it dimensionless, then you have to multiply it by 1000. For example, Kc equal to Qe divided by C into 1000, because here it is written equilibrium constant Kc was made dimensionless by multiplying 1000 gram per liter for C in milligram per liter and Q in milligram per gram unit, since the solution density is 1000 gram per liter or 1 gram per milliliter. So you can easily calculate Kc. So, for example, is the highest adsorption. Kc is QE divided by C into 1000. So this is Kc for 25 degrees Celsius. Similarly for 35, 45, and 55 degrees Celsius. So we have calculated Kc for 4 different temperatures. Then you need to take ln Kc. So ln Kc equal to ln into this. Then enter this. So these are the ln Kc value at 4 different temperature. Then our temperature was 298 Kelvin, 308, 318, and 328. It is made in Kelvin. Just adding 273. Then you need to convert it to 1 by T. Just 1 divided equal to 1 divided by this one. So you get this. Similarly, you can also calculate 1 by T for this and that. So then you can directly calculate del G value from ln Kc. For example, del G equal to minus RT ln Kc. So here minus R, R means temperature, R means 8.314, T is this temperature, ln Kc, this value. So you can direct, then we convert it into kilojoule per mole. So we divide it by 1000. So this is our del G value for this temperature. Similarly, you can calculate this and that. So we have already calculated del G value, gives free energy. Then we need to calculate enthalpy as well as entropy. So in order to calculate enthalpy and entropy, you need to plot ln Kc versus 1 by T. So if you plot ln Kc versus 1 by T, you will get a slope of minus del S by R and intercept equal to del S by R. So using the values of slope and intercept, you can easily calculate enthalpy change as well as entropy change. So here is the plot ln Kc versus 1 by T, and if you draw a straight line, then you get this one. That is, slope is equal to minus 3954 and intercept is this one. So using this value, using slope equal to minus 3954 equal to del S by R. That means del A is equal to R into this slope. So you can easily calculate del S. And intercept 20.32 equal to del S not by R. That means del S equal to R into this intercept. So using this value, you can easily calculate entropy. So this is how you can calculate thermodynamic parameters using MS Excel. That's for today. If you have any query, please let me know by comment. Thanks for watching.